Hola, mi clase. So we're doing 10-1. This is properties of dilations. So we've heard of dilations, right? That's what our pupils do when they grow for light, getting more light, and then shrink when there's a lot of light, right? So that's what our pupils do. That's where that term came from. So we dilate a figure given a scale factor, and we can write an algebraic expression of the dilation. I guess technically this is really 10-1 and 10-2. I'm not sure if I put that on your guys' note takers, but it is technically, we're going to just combine 10-2 into here, okay? So a dilation is a kind of transformation that enlarges or reduces a figure. So we saw that a little bit on our quizzes the other day. So the center of dilation is a point of intersection of lines through each pair of corresponding vertices in dilation. So basically, it's the point in which we're dilating. Most of the time, we're going to do the origin. And then an enlargement is when it increases, and a reduction is when it decreases in size. And then the scale factor is the ratio used to enlarge or reduce a similar figure. It's the number that we make, how big we make it and how small we make it, okay? It's what causes it to get bigger and smaller. Make sure you pause and write all this down. I know it's a lot of vocabulary, but make sure you write it down. So we're gonna first start by dilating by a factor of a fourth. So you can see this is clearly a ratio, right? It's 1/4. So let's first write down these pre-images. I'm actually gonna label them A, B, and C. We'll put A, B, and C, and then over here we'll have A prime, B prime, and C prime for our image, right? So we need to go find A, B, C. So A is at 1, 2, 3, 4, negative, because I went to the left, and then 1, 2, 3, 4. B is at 0, 1, 2, 3, 4. And C is at 1, 2, 3, 4, negative, comma, 0. So a scale factor, right, is this. This is our scale factor. It's what's going to cause it to either reduce or enlarge. And so we're going to write, I'm going to have us write an algebraic expression first so that we kind of understand what we're doing. We're going to go xy goes to, and the way we write our algebraic expression is we go 1/4 x, comma, 1/4 y. And what we're gonna do is we're actually gonna multiply all of our x's by a fourth, and we're gonna multiply all of our y's by a fourth. So the scale factor has to go to both x and y for it to be a true dilation. If I dilate just x, it's gonna become not the same shape. And if we remember from our definition, it's a different size, but the exact same shape. It will not cause, it will, if I don't dilate both, it'll cause it to become a different shape, actually, and we don't want that. So we're going to do both. So what it looks like is we would go 1/4 times, and I'm going to go -4/1 so that it becomes a fraction as well. And we multiply across, and we get -4/4, which gets me -1. So I'm going to get -1, and then I'm going to do it again for 4. So I'm going to go 1/4 times 4/1. We get 4/4, which just becomes 1. So A prime is at -1, 1. It's supposed to be a prime. So we know the 0 times a fourth will just get me 0. And we already did 4 times a fourth. It's right here. It was 1. So that's what's really nice about this is a lot of the time the points are the same. So we don't have to multiply everything. I'm already done. 4, I already did 4. It's right here. It's 1. So B prime goes right here. And then the same thing happened for C. C prime was at -4. We already did that. It got me -1. And we know that 0 times a fourth is just 0. So it goes right here. Look at that. Look at that itty bitty triangle. So notice it is still the same triangle, but it's smaller. Okay, and I want you to also notice, look, the side length was 1, 2, 3, 4. 1, 2, 3, 4, and now it's 1. Well, 4 times a fourth is 1. And so you can see that even the side lengths get changed, and that's what keeps it the same shape, is the fact that the side lengths also get either reduced or enlarged. Okay, so this is how we do it. This is what your algebraic expression looks like. So this is a reduction, right? This is a reduction. Actually, let's write that. Reduction. Alrighty. So now we have dilate the following by a factor of 3. So this is still my scale factor. We can consider it still a ratio because if I needed to, I could write it as 3/1, right? So it's still considered a ratio. So we're going to do the same thing, right? So our algebraic expression would be xy goes to, and we go 3 times x, 3 times y. So it's just a multiplication. This is the newest one we have. That's why we've never written them like this. So if I take A, it's at 1, 1, and B, 3, 1, and C is at 1, 3. What I'm going to do is I'm going to take 3, times 1, and 3 times 1, and A prime is going to become 3, 3. And then I'm going to take 3 times 3, and 3 times 1, and B prime is going to become 9, 3. Notice I put the scale factor first every time. Okay, this is the scale factor right here, 3, 3, 3, 3. The first one's always the scale factor because if you notice in my rule, it's written the same way. So I'm going to go 3 times 1, comma, 3 times 3. I'm going to get C prime to be 3, 9. All right, let's go graph these. So 3, 3, A prime. 9, 3, B prime. And then 3, 9, C prime. Oops, I'm not at 3. I'm at 2. There we go. So, and now we can see that this was actually enlarged. It's really bad, E and an N, but enlargement. So everything, all the points were multiplied by 3. If we notice, this was 2 apart. Now it's 1, 2, 3, 4, 5, 6 apart. Well, 2 times 3 is 6. This was also 2 apart. 1, 2, 3, 4, 5, 6. So again, the lengths also change by that scale factor. Everything changes by that scale factor. If I do not change everything by 3, then it will not be the same shape. It will just be some random shape. All I want to do is take this shape and make it bigger by the exact same amount. All right, so this is kind of a little backwards. This is similar to our quizzes actually, where they gave you, the pre-image and gave you the image and asked you to find out what happened to it, right? So same idea. Now it says find the scale factor of the following dilation and write an algebraic expression of the dilation. So what we have to do is look at D and D prime and E and E prime and F prime and G prime and find out what they changed by. So let's go first list our D, E, F, and G's. So D is at 410. E is at 1010. F is at 10.6. And G is at 4.6. So then what I'm going to do is I'm going to list my D prime, my E prime, my F prime, and my G prime. So D prime is at 2.5. And E prime is at 5.5. And F prime's at 5.3. And G prime is at 2.3. So remember how we said the scale factor was a ratio? Well, it's my ratio of my image compared to my pre-image. This is the ratio. So what I'm going to do is I'm going to write them, and I'm going to go, well, 2 over 4 is a half, and 5 over 10 is a half. I don't really need to check E because it's 5 over 10, a half, 5 over 10, a half, 5 over 10, a half. I have one more, I have 3 over 6, so if I go 3 over 6, well, that's a half as well. I already did 2 over 4, that's a half. 3 over 6 is a half. So we can see that all of these are a half. So there's my scale factor. So my scale factor is a half. We also can check that with the side length. So it was 1, 2, 3, 4, 5, 6. It's now 1, 2, 3. Well, 3 over 3 6, right? Image to prime is a half as well. So I can check that too. And then here, 1, 2, 3, 4, 1, 2. Again, oh, I can't write. If I check 2 over 4 for the side lengths, it's also a half. So everything is a half. So that's how I know it has to be that. So then if we write our rule or our algebraic expression, we're going to go x, y goes to a half x and a half y. Alrighty, I want you to try to do this one. Okay, so I want you to notice this is my pre-image, blue, and then I'm going out to my image, green. Okay, and I want you to go find the scale factor and the algebraic expression. It would be a very good idea to do it just like I did this one, but you are doing this one. All right, so the main things I want you to remember, and I wanted us to, I'm actually going to start it, but we're not going to finish it, is that an enlargement is blank 1, and a reduction is blank to 1. So what we're going to do is I'm going to finish these in class where we're going to discuss what is the relationship from an enlargement and a reduction to the number 1. Okay? And we're going to fill this in. Okay? That way, I don't know why I put reductions, an S here. Reduction, there we go. That way we can have it when we get together. Okay? So the independent practice is similar to the first problem we did. It says dilate the following figure by this scale, 1/3. So again, list the points and times it by 1/3. And then you're going to write the algebraic expression to describe the dilation. Okay, so this is identical to this one, okay, the first one. All right, that's it. Adios. Until next time.